So good morning. So today we will start our new subject, mass transfer operation. So whenever we study any subject, we should know why we are learning that subject, what is that subject and how it works. So why, what and how. So first question should come into our mind is why we are learning mass transfer operation. So chemical process industry is concerned with upgradation of material to the form in which it was more useful and fulfill the need of market. So all raw materials are naturally occurring or based of naturally occurring raw material. So when all raw materials are naturally occurring, so it will not be in pure form in nature. So we need purification, enrichment, segregation, separations, and that what we need to do it by mass transfer operations. So that's why we are learning mass transfer operations. So objectives of mass transfer operations. So the objectives is to discuss the fundamental concept of mass transfer principles and to apply those principles to real engineering problems. Mass transfer operation will provide an overview of mass transfer operation at a basic to an intermediate level, and coverage will be relatively broad. So once you learn the topics involved in mass transfer operation, and if you properly go through our lectures, I can ensure you that you will be having a relatively broad knowledge of whatever unit operations or mass transfer operations we are covering in this subject. The goal is to provide with the theoretical or analytical background to understand mass transfer operations and to tackle the sort of complex problems. So we will ensure after completion of the subjects, after completing the complete course, that whatever complex problems arise in mass transfer operation, we will be able to tackle and sort it out. We will be able to design, develop, and operate all the mass transfer operations what we are going to learn in this subject. So that we have to ensure after learning this subject. That is our objective. So this is detailed course plan. This is our syllabus. First unit is diffusional mass transfer and mass transfer coefficient. You know, diffusion you have learned in your in schools in your 10 plus 1 and 10 plus 2. So diffusion, if we put a lump of sugar in water, we know that the sugar molecules will dissolve and diffuse in the water, and then it will get uniformly distributed throughout the water. So that is diffusion. And mass transfer coefficient is when there is diffusion or mass transfer between two phases. So the boundary form around these two phases will cause resistance to mass transfer. So knowing this resistance or knowing this mass transfer coefficient, we will know how fast or slow our rate of mass transfer will be. So this we are going to study in details. Second unit is distillation. So distillation is very important unit operation in mass transfer operation, or the most important unit operation. So distillation is basically is the separation of the separation of a liquid mixtures into its constituent or into its components by using difference in vapor pressure is distillation. Distillation is basically the function of distillation is to separate a liquid mixture into its individual components, or in some cases into group of components by vaporization. So distillation is basically separating the liquid mixtures into its constituent part. So distillation is one of the most important unit operation or mass transfer operation in chemical process industry, and very famous fractional distillation of crude oil we all know. The crude oil is separated into petroleum gas, gasoline, naphtha, paraffins, diesel, fuel oil, lubricating oil, and bitumen. Third unit will be absorption, or famously called as gas absorption. Gas absorption is basically separating the gaseous mixture by using liquid solvent. Is gas absorption. This we will go through in details when we will start this unit. Fourth unit is liquid-liquid extraction and solid-liquid extraction, or combined it is called as extraction. In liquid-liquid extraction, we separate the liquid-liquid solution by adding a solvent which is completely immiscible in the initial solution, or at least partially miscible. And then we separate these liquid mixtures. Is liquid-liquid extraction. So liquid-liquid extraction is basically used to separate the liquid solution by adding a liquid solvent which is completely miscible in the initial solution, or at least it should be partially miscible in the initial solution. And then we separate these solutions. And then solid liquid extraction is extraction of a solute from a solid by using a liquid solvent. The best example is the tea. We use this example we do in our day-to-day life very frequently. In the morning we have a tea. What we do is we extract a tea from a tea leaves by using water at its boiling point as a solvent. So we extract tea from tea leaves. So we preferentially extract tea from tea leaves, from a tea bag or from a tea leaves by using hot water as a solvent and extract tea. This is example of leaching, solid liquid extraction. So from a solid, which is a tea leaves, we extract tea by using water at its solvent, water at its boiling point as a solvent. Another example is extraction of edible oils or essential oils by using liquid solvent. For edible oil extraction, we use light hydrocarbons like hexane. So what we do, we extract edible oil from edible oil raw material like groundnut, cotton seed, or from sunflower. We extract the edible oil by using hexane as a solvent. So we extract oil from a solid material by using a liquid solvent. Or we extract essential oils from flowers, from sandalwood by using water at its boiling point as a solvent. So this is leaching. Then drying and crystallization. Drying is removal of moisture from a solid material by using gaseous medium. So drying is basically removal of moisture, removal of liquid from a solid by using gases as a medium, usually air. So drying is very common mass transfer operation, we all know. And then crystallization. So this we are going to study in details. And last unit is our adsorption. Adsorption is removal of a solute from a gaseous or a liquid solution on a solid surface is adsorption. So these are the topics we are going to cover in our mass transfer operations. So today I will keep my lecture focused on introducing the mass transfer operations. So what are the central topics in chemical engineering? You know, chemical engineering, as I have told in the start, that chemical engineering is concerned with upgradation of material. So a substantial number of unit operations of chemical engineering or chemical process industry are concerned with problem of changing the composition of solutions and mixtures through method not necessarily involving chemical reactions. So usually these operations are directed towards separating a substance into its component parts. So the central topic in chemical engineering is synthesis of material, where from the natural raw materials we produce a product which is useful in the market by chemical reaction or by non-chemical reactions. like in crude oil, we separate into different products. There was no reaction involved. So that was also synthesis of materials, right? Second is remediation of polluted air, water and soil. Many chemical processes create a large amount of air, water and soil pollution. So we need to take care of this. Like we hear in many process industries, the obnoxious gases, poisonous gases are emitted in the atmospheric air. So we need to take care of it. We need to purify all these obnoxious gases, poisonous gases. We need to take care of all this uh, air pollution problem in remediation of polluted air. Also, we need to take care of pollution which is going into water and soil. For soil, like plastic waste, once you use the plastic, we throw it into atmosphere and it goes into soil and cause a pollution. So we need to give some remediation solution for this. So we need to recycle the plastics, or we do some processes like pyrolysis or incineration to take care of this solid waste, which ultimately will goes into the soil and degrade the soil or create a pollution. So we need to take care of this. So that what we are going to do in chemical engineering. And energy. So all chemical processes required energy in one form or another. So all processes will need energy. And even energy generation, chemical process engineer has great role to play, like in solar energy or in nuclear energy. So we have great role to play in energy generation also. So let's introduce ourselves to the mass transfer operations. So separation of chemical mixtures into their constituent has practiced from long time. Even when chemical engineering was not founded or started, the extraction of materials and mass transfer operations are practiced from very ancient time. For example, extraction of metals from their ores, perfumes from flowers, and dyes from plants are practiced from ancient times in the world. Distill of liquor. So even when chemical engineering was not in existence, this extractions was carried out from long time. So like evaporation of seawater to obtain salts. So mass transfer operations or separations are done from ancient time. So separation of chemical mixtures into their constituent has practiced from long time, as I have already told you. So a substantial number of unit operations, as I have already told you, in chemical engineering are concerned with problem of changing the composition of solutions and mixtures through method not necessarily involve chemical reactions. So though chemical industry, the central part is chemical reaction, but in chemical industry, although chemical reactor is the central feature, but the separation processes dominate the cost. So the cost of any product produced, separation processes dominate that cost. So the importance of these operations are profound. There is hardly any chemical engineering process which do not require primary purification of raw material so that the chemical reaction should be proper, or final purification of product from its byproducts to remove the unreacted raw material. So these mass transfer operations are very profound, very important. And the separation cost depends on the final to initial concentration of the separating substance. If the ratio is large, then the product cost is large. For example, sulfuric acid is relatively very low cost because the sulfur found in nature in pure state. So you don't need much of the purification. Whereas in uranium, the cost of uranium is very high as it found in nature at very low concentration. So the cost of separation is very large in case of uranium. So that's why its cost is very large. So the separation cost depends on the final to initial concentration of the separated substance. Sulfur is found in relatively very pure state, so the cost is less. Uranium found in very low concentration, so its cost is very high. So for mixtures, such separation may be entirely mechanical. I have told you that in unit operations are concerned with problem of changing the composition of solutions and mixtures. So we are changing the composition of mixtures and solution. So for mixtures, such separation may be entirely mechanical. For example, filtration of solids from suspension of liquids. Like the example shown is suspension of chalk in water. So we have a filter paper and we separate that chalk from the suspension of water by filtration. So this separation is entirely by mechanical means. Like obtaining different particle size fractions by screening. So we separate particle of solids into fractions of different particle size by screening. Or the separation of particles of ground solid according to their densities. So these separations are entirely mechanical. So you need to understand what is the difference between mechanical operation versus mass transfer operation. In mechanical operation, the separation is entirely by mechanical means. Usually mixtures are separated into its constituents entirely by mechanical means. Whereas in mass transfer, the separation of solutions involves the change in composition of solutions, involves the changes in the compositions of solutions. So they are known as mass transfer operation. And that's what we are focusing in this topic. So what is mass transfer? So mass transfer is basically net movement of component in a mixture from one location to another location in the presence of difference in concentration or partial pressure. Remember, we are defining mass transfer in which the net movement of component in a mixture from one location to another location. And this transfer should be in the presence of difference in concentration or partial pressure. For example, if we transfer material in a belt conveyor, is not a mass transfer because the transfer of material from one location to another location is there, but it was not in the presence of difference in concentration. That was by mechanical means we are transferring the material in a belt conveyor, right? If I have a pen, I put that pen from one location to another location, will not be mass transfer operation because that transfer of that pen from one point, from one place to another place is not due to difference in concentration. That is due to mechanical force I applied and put that mass from one location to another location. Let's give me another example. If the liquid is transported into pipelines through pumps or by gravity, is not mass transfer operation, though it was transferring of mixture from one location to another location. But that was not due to the presence of difference in concentration or partial pressure. So that is due to pressure gradient. That is due to gravity that has transferred. So mass transfer is the net movement of a component in a mixture from one location to another location in the presence of difference in concentration or partial pressure. So partial pressure we use to measure the concentration in gases. Let's take some day-to-day life example. So like this lump of sugar added to a cup of tea, we know will dissolve and diffuse throughout uniformly. And that we have already discussed. So if we open a perfume bottle, we know we sense a fragrance because the perfume has diffused in the atmosphere, and then we can sense that perfume is nothing but a mass transfer operation. That transfer of that perfume is due to concentration gradient. The mass transfer of a lump of a sugar into a water solution is due to difference in concentration. And then once it gets uniformly distributed, this mass transfer gets stops. At macroscopic level, the concentration of sugar will be uniform and as mass transfer will get stopped. Drying of clothes under sun. The moisture of the clothes will diffuse in atmospheric air due to difference in concentration. Is a mass transfer operation. So anything when the component is transferred from one location to another that was in the presence of difference in concentration is mass transfer operation. So let's study some industrial examples. We have talked of day-to-day life example, but since we are learning it to design, develop, and operate mass transfer operations or unit operations in chemical process industry, we need to see the industrial example. So first is separation of CO2 from flue gases. So we know it is a gaseous mixture. The flue gases is a gaseous mixture and CO2 in that flue gases will be a gaseous mixture. And if you remember, I have told you that gaseous mixtures are separated by a process called gas absorption process. So gas absorption is a gaseous mixture is separated by a liquid solvent. So if we use any liquid solvent which preferentially removes CO2 from flue gases, we select a solvent and remove or segregate or separate CO2 from flue gases. The other gases in the flue gases will not preferentially dissolved in the liquid solvent. The reason is because we have selected a solvent which will preferentially remove CO2. So the solubility of CO2 in that gases is very large, and the other gases in the flue gases, the solubility of that gases in that solvent will be negligible, or it will have no solubility at all. So that's why preferentially CO2 will get removed from a flue gases by using a liquid solvent is called as gas absorption processes. The separation of mixtures of ethanol and water into its components. So the process used to separate the liquid mixture of ethanol and water into its component is called distillation process. So distillation, what we do is, suppose we have a liquid mixture of ethanol and water of some composition. Suppose we assume it that ethanol and water is 50-50% composition. And we want to separate that, we want ethanol to be 70% pure ethanol. So what we do, the liquid solutions, we vaporize some amount of liquid. And the vapors formed will be richer in the component having more volatility or having more vapor pressure. And in our case, ethanol will be having more vapor pressure than water. So when the vapors are formed from the liquid, the vapors will be richer in ethanol than in water. Because when you vaporize the liquid solution, the vapor will be richer in the lighter component, the component which having more vapor pressure. And in our case, it is ethanol. So the vapor will be richer in ethanol than in water. Initially, our solution is 50-50% composition. Part of the liquid, suppose 20-25% of the liquid is vaporized. The vapor will be richer in more volatile component, that will be in ethanol. If we condense this vapor, we will get another solution which will having more ethanol and less water. So suppose that composition has 70% ethanol and 30% water, and that in that way we have separated ethanol and water into its components by distillation process. So in distillation, we have a liquid solution which we want to separate. So we created another phase, the vapor phase, right? And then we separated. Then another unit operation is separation of mixtures of toluene and water using benzene as a solvent. And that process is called as extraction process. So we have a mixture of toluene and water. Toluene and water is a solution which is miscible. Toluene and water are miscible in each other in infinite form at any concentration. So we want to separate this toluene and water. So what we do, we add a benzene. So benzene will be immiscible in the solution of toluene and water. So we want a solvent in extraction such that that solvent should be completely immiscible in the solution, or at least it should be partially miscible in the solution. So we have a solvent benzene which will be immiscible in the solution toluene and water. So we add benzene in this solution, and then what will happen? The solution is immiscible in benzene, but toluene do have solubility in benzene also. So some toluene will get transferred into benzene also, and in that way some amount of toluene has been removed from toluene water solution by using benzene as a solvent, and this process is called as extraction process. So we are separating the liquid mixtures by using a liquid solvent, and it's called an extraction process. And leaching is solid liquid extraction. So we are removing a solute from a solid by using a liquid solvent. I want to give you one example for solid liquid extraction, so which was not on our presentation. So solid liquid extraction is extraction of metals from metal ore by using a liquid solvent. For example, we have a gold ore. So in this gold ore, we have some amount of gold inside this ore and other material also. So we want preferentially remove gold from gold ore. So we will use a liquid solvent, isocyanide, as a liquid solvent, which will preferentially remove gold from gold ore, and in that way we will separate gold from gold ore. So that is solid liquid extraction. Another industrial example is drying of wet solid such as wood with the help of air. So that for that we will require a process called drying process. Drying is usually removal of moisture from a solid material by using air as a medium. But drying is also removing a liquid, like when we form a plastic sheet. So on our plastic sheet, when we form a plastic sheet in a polymer industry, the solvent is there on the plastic sheet, and we want to dry that solvent from that plastic sheet. So in that case, drying is removal of that solvent by using air as a medium. But in general, drying is removal of moisture by using gases, usually air, as a medium to remove the moisture, and that is called as drying process. So there is crystallization, solid liquid extraction, adsorption. So several industrial example, but we want to, in introduction, I don't want to make it very complex. So simply these are 4 processes, mass transfer operation processes, and few more processes we are going to learn in mass transfer operation in detail. So that's all in today's lecture. So from tomorrow we will start in details about mass transfer operation. So if anybody has question regarding mass transfer operations, so you can ask me. So I will wait for a couple of minutes for your questions, and we will stop our lecture today.
So I want to ask about vacuum distillation.
Okay, right. Okay, I will tell you about vacuum distillation. Any other questions related to today's topic? So why we are learning mass transfer operation? What is mass transfer operation? Have you understand what do you mean by mass transfer? Have you understand what do you mean by mass transfer? Okay. So have you understand that in in 4 industrial processes we have studied, the common thing is we have two phases. Like in gas absorption, we have two phases: gases mixture, and we are using liquid solvent, so we have gas liquid phase. In distillation, we are separating the liquid solution and we are creating another phase, a vapor phase, by adding energy. So again we have a gas liquid phase, so we have two phases. In extraction process, we have a toluene and water solution, which is a liquid phase, and we are adding another solvent, which is also liquid but which is immiscible. So we have again two liquid phases, two immiscible liquid phases. In drying, we have a solid and we have a air, we have two phases. So all the processes, we have two phases and we are utilizing some property for separations. Like in gas absorption, we have two phases, gas and liquid, and difference in solubility, we are using that property for separation. In distillation, we are using difference in volatility or difference in vapor pressure as a property for separation. In extraction, difference in solubilities. In drying, difference in solubilities. So we are utilizing some property for separation, as well as in all processes we have at least two phases. That's the common in all processes. Now I will come to your question. Again, I will ask the other participants or other students if they have any questions regarding to today's topic. I will wait for your questions. Any question about mass transfer operation, books, what types of books you should use, how to study, the basics of subject. Please get a habit of asking questions. That is the best way to discuss any subject, best way to discuss any topic. And I want you to go thorough to mass transfer operation. It will help you in GATE, it will help you in many competitive examinations. And believe me, if you go through all lectures properly, you don't need to study GATE, mass transfer operation for GATE examinations or any competitive examinations.
We will prepare for.
Huh? I'm not audible, beta. Please be loud. What you said?
Sir, which book we will prefer for mass?
Okay, we will start with mass transfer operation, Robert Treble, R.E. Treble. And one more thing I want to focus here. Don't use any ordinary book for learning any subject. Use best reference book used throughout world, like mass transfer operation by R.E.